Good morning, guys. Jagrat, you are saying, could you please explain self keyword one more time? Don't have much experience with C++, so feeling a bit uncomfortable with the keyboard. And sorry for asking this question as well. Okay, it's no problem. Let us continue with the one simple class, and then probably those who are kind of not coming from C++ and if they're finding little bit difficult to understand what that self is, let me clarify it or let me make it a little bit simpler to understand. Okay, so let's see how it does the job. Basically, a self is, you can consider this as a keyword, or you can say it's a kind of a convention. Conventionally, all the methods which are part of your class, they generally will accept the first parameter as a self. Not necessarily as a self, you can change that with anything. It's not like it's a keyword that you have to use. You can literally change it to anything, literally anything. I mean, if I start with a class, let's say class person, again, this is for everyone, so please pay attention. Jagrat, you will going to get the answer here as well, but others, though, you will also get an answer here. So if I say a class person, very simple class, and I want to start with the class, say with name, address, and age, again, as simple as that. We generally start with its initializer. So we say it is an init method, and generally we say this is going to be name, address, and age. This is what we started yesterday. So probably what we do here is, like, when we are using any of the methods, we use the first parameter as a self. Now, what is the self here? The self here is nothing but the object on which the method is called. For example, let me first mention this word self here, and then we'll continue further, and then we will consider that what self generally turns out to be. So this is underscore underscore address, which is equals to address, and self underscore underscore age, which is equals to age. So this is generally the way we start writing the class. Now there are a bunch of other methods we can define. For example, I just add only one for testing again. So this is a print info, and pay attention to this parameter again. It's a self parameter. So every method in your class is going to have a self as a first parameter. So probably I'm going to come back here and say, hey, I want to print the name. So to print the name, I'm going to say name as usual. Hopefully this is going to be address, so which is going to be self underscore underscore address, and print the last one here is like self age. So this is going to be self underscore underscore age. That's it. A very simple class having three members or three attributes, name, address, and age, which are kind of private now. So hopefully you can recall. I think we already have discussed this yesterday that when you're using a class with members with prefix underscore underscore, those members or those attributes will be converted or will be turned out to be private members. So you cannot modify them externally. So that's what we discussed yesterday. Now, when you create an object of this, say P1 is equals to person, and if I pass, let's say, a name which is equals to, say, person 1, maybe I can say address is equals to Pune, and say age is equals to, say, 20, for example. So when you say something like this, see what happens behind the scene. So behind the scene, it creates an object, literally it creates an object, and then it passes, the init method. I mean, it calls that init method and passes that P1 parameter here. So probably you can understand now that this name, whatever name we are passing here, let's say person 1, or maybe I can just copy and paste this. So behind the scene, it creates an object for you, and it gets the address, and it passes here as a first parameter of this method, init method. Actually, this init method is from person. So you can say that it's person dot underscore underscore init. Then it passes this P1, and then it passes the remaining parameter. So this happens behind the scene. So again, what is the self then? Self is nothing but the first parameter of every single class method, which turns out to be an object on which you're calling the method, or the reference you are dealing with at that moment. So I'm dealing with the P1 right now. So this is nothing but my object I've just created here. And that object is where we are adding name, address, and age attribute. Maybe if I just go back here and say print info at this moment. So again, this call gets converted into person dot print info like this, and then it passes the P1. So again, what is the self inside this print info? It is nothing but the object on which you are calling the method. So I'm calling this method on P1. So basically this self, when the method gets called, will point to this P1, and whatever happens will happen in the context of that P1. Let's come back here and create another object. Let's say P2, for example. So this is the P2. And if I want to create one more object, say this is going to be name, say person 2, say address, which is equals to say Mumbai again, and I'm sorry, Mumbai, and then the age, maybe I'll say age is equals to 30, for example. Again, what happens behind the scene? Behind the scene, it calls that function init underscore 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 init underscore underscore, and then it passes the p2 and then the rest of the parameters. Again, when you say p2 dot print info, what does it do? It passes that, or it calls that function. I mean, Python calls that function person dot print info, and it again passes the parameter p2. So when you call this method print info on p1, this method, inside this method, self will point to p1. When you call this method on p2, the self will point to p2 there. So basically self is the parameter which is pointing to the current object on which you have called the method. I think Jagrat, that must have made the things clear. If not, then ask the question again. Okay, Rohit, your question. I'm facing one issue. I'm passing age as integer in init, but print info is treated as a tuple. No way. When you say run this code, probably you will say this as a simple integer. So you can't get this as a tuple. If you're getting it as a tuple, that means you're doing something wrong there. Maybe you're using some other things, or I don't know. Just put your code there on console or on chat, and then probably we'll see what is wrong with it. Okay. Jagat, are you there? Have you got the concept? I mean, is there any problem still you are facing? So you are having a small problem here. Rohit, if you look at the self.h, there you are having a comma. Can you see that? In your init method, you said self dot underscore underscore h is equals to h comma, and that is the reason why it is doing it. Okay, it's a small, I mean, very silly mistake, but it's okay, it happens. So if you say something like this, it will turn out to be a kind of a tuple. Okay, because you know that whenever you add a comma, by default it is going to get converted into comma. Okay, it is mandatory to use self. If you not use the code, it will give an error. No, of course not. I mean, you can change it to something. For example, you can change it to person. It doesn't matter actually. So if you're using person, still everything is going to work. See, if I'm going to run that application, everything is going to work. There is no problem at all. So it's not a keyword as such, but you can say it's kind of a parameter which will be accepted in every single class method. And it turns out to be that method, the one which you are calling right now, or rather on which you are calling right now, that will be considered as the self. So it is not at all mandatory to use self as a first parameter, but you know what? It's a kind of a technically said, like whenever you are talking about that print or print info, for example, it is pointing to P1 or P2 depending on which object on which object you have called this method. So it is said that this parameter is talking to, or this parameter is pointing to that object on which a method is called, and generally it is referred as the self. Self means it's kind of the current object. Self means it's the current object. That's what you can see here. But again, it's not at all mandatory. It's not like other languages where you are using this, I mean, in C++ or something like Java. So forget about those languages. I don't care about them right now. So I do care about Python, and in Python, it's not mandatory that you have to use self here. It is convention that you can use the first parameter as a self, which says that self means it is a current object. That's why it is used as a self. So Jagrat, I think if you change it to person, everything will work as per your expectation. See, the only thing you have to make sure that you are using self, sorry, you are using person in place of self. When you are in PyCharm, it tells you that don't use this as a person, just use it as a kind of a self. This is a kind of suggestion. Again, it's a convention. So generally, when you see any Python code, by default, it is considered as a self. I hope that must have made the things clear. Okay. Pranit, your question. I came across one more underscore method in object underscore new when it is used. Pranit, wait for some time because I'm going to talk about some interesting facts, not right now, once we are done with object oriented, then we'll talk about this underscore new. Okay. Just to answer very quickly, this method generally creates a new object, but there are some implications and there are some scenarios where we have to use this underscore new. Okay. We'll talk about that later. Adesh, can you please draw the diagram? It clears one more. It clears more those who doesn't know this pointer. I don't think it requires any kind of diagram as such, but still, if you insist, I think this is exactly same thing what we have seen earlier. So probably I'm just going to go back here. I'll open the existing diagram and I'll update it instead of drawing a same diagram again. I'm just going to update that. So not this one. Yeah, this one probably. You can say, should I? Not this one, not this one. Where is it? Where is it? Do we have a class diagram? Okay, here it is, for example. So basically, when you talk about this diagram, you can see that whenever you are calling about when you are calling this method, or sorry, whenever you are creating this object class person, maybe the person is the object you are creating. It is going to create two memory blocks like this. Inside this person, the self, whenever you are referring to, that self will point to this particular person. Actually speaking, if you look at this code, I think it will clear many different things here. So behind the scene print info is going to get called like this, person.print info, and the p1 will be passed as a first parameter here. This p1 will be accepted as a self. Again, when you are in Python, it's not mandatory that you should use a self. You can use self, you can use something else as well. But again, it's a recommended. And as I said yesterday, there are many conventions we follow in Python, and as conventions, I mean, as per the Python's convention, we use this post parameter as a self. It's not a kind of a keyword. It's generally, think about it as a first parameter of a class method. Okay, nothing other than that. Okay, so now this is something we have seen yesterday. Let us continue further and see how we can extend this class. By the way, before we go to the other topics, do you have any other question? Do you want me to repeat anything? If yes, then do it right away so that the link will not get broken in between, because now I want all of your full concentration. The topic we are going to start is a little bit bigger and I don't want to break that link in between. So if you have any question, let me know right away so I can answer it and then we'll go further. Any questions so far? No question. Okay, fine. So let us continue further and see how we can, I can't able to pass P2 as an argument. Which part you are talking about, Adesh? I'm not able to understand what exactly you are doing there. Unless I see your code, I will not be able to get what you are doing. Which one you are saying, Adesh, quickly? I10, this one. So there is nothing, I mean, there is no problem at all. So what is the problem there? If you, right, but what is the problem? I don't see any problem there. It's absolutely fine. There is no problem. It's not taking I10 showing error. I10, no way, it should. It should. There is no problem in that code at all. So probably if you can see that car class, I think we already have done that yesterday. Okay, let me do it quickly. So class car, and probably you can say this is a def underscore underscore init underscore underscore. We need three things. I hope you are passing three things. That's model, company, and price. You know, it seems like you are using public member. So probably I can say something like self dot model is equals to model. Okay, then self dot company is equals to company, and self dot price is equals to price. Probably I'll just go back here. As you say, I10 is equals to car, and what that you are passing? Car I20. Oh, I didn't see this. What are you passing there? Look at this, what you're saying here, sir. You can't pass I20. What is I20 here? This is not at all right. I mean, how do you pass that there? Exactly, I didn't see that here. This is wrong, you know. So you can't pass I20. If it is a model, then you are already passing that model here. And if it is a model, then it has to be converted. It has to be added into. This is what I was asking for. Yeah, this is wrong. Sorry, I didn't see that first parameter there. So this is wrong. You can't pass I10 into I10. This is completely wrong. How can you do that? Because you see that when you're talking about that car construction, it is not accepting any parameter, right? So it is accepting self, name, address, and age, except underscore underscore init. Other things are exactly like this, but for underscore underscore init, this is how your call will turn into. So probably if I just say I10, 1 second, let me say Hyundai, what you said last time, and price you are passing it as a 5.5. So this call gets converted into something like a car underscore underscore init underscore underscore. Then it will pass I10 here, and then the rest of the parameters. Okay, so this is how the call gets converted to. right? I'm just asking that is possible to pass manually. Aha, okay, so that's what you are asking. Okay, let me answer that question in that way. This is for you and for all of you rather. This is internal representation, or this is internal code conversion. Now, hopefully, you must have got the answer. This is internal. And when I say internal, this is not for a developer. This is how the Python will take care of converting your code internally. Okay, so you can't do this. Python will do it on behalf of you because it's not as simple as you think. It does so many adjustments and then it calls that. See, ultimately, this is nothing but, I mean, the code, the Python we are using right now, it's a C Python. C Python means it's a kind of C code, it is running behind the scene. So internally, it does the pointer arithmetic and then it passes that as a pointer. So Adesh, it's not for you, it's for Python. You can't pass that as a parameter which I showed here. This is for internal Python. So Python does that adjustment internally. You can't do it. Okay. Yes, no problem. You got it now. That's good. I know that what you're talking about, but this is not for you. This is for Python. I was telling you so that you can understand what that self is. Self internally is nothing but P2. So ultimately it is going to point to P2. Okay, that's what I was saying that. Pranit, in this case, the argument mismatch might occur. Yes, it will give you argument mismatch because it is expecting 3 parameters and you are passing 4. This parameter is a kind of a hidden. You can't touch that parameter. This will be handled by Python itself. Okay. The only difference here, if you are coming from other languages, then for your understanding, the only difference is other languages like C++ and Java, they hide this parameter. The parameter is called as a this there, and this parameter is hidden in those languages. In case of Python, this parameter is visible. That's the only difference between Python and other languages. Rest of the things are absolutely right. Absolutely same. Sorry. Okay, so I think you got the answer. That's good. Now let's continue further and see the next point. As I said, the next point is a little bit bigger. So let's pay attention. I want to just complete this session, complete this entire reusability in today's case. I know it's very simple to understand, but it's little bit lengthier. So let us see how it can be done. Okay. Jagrat, if I leave that empty, that will work. No, you have to pass that first parameter there. No, Jagrat, that is not going to work. You have to pass that parameter there. This is mandatory. As I said, there are a few things which are, in which case every language will give you kind of compulsory things. Like when you are in C, you have to follow C syntax. When you are in C++, you have to follow C++ syntax. When you are in Python, you have to follow the Python syntax. And structurally or syntactically, whenever you are creating a class method, every method is going to accept the first parameter as either self, or you can name it anything, but the first parameter is mandatory, and that will be handled internally. That will be kind of handled internally. It's not for you. Okay, good. Okay, let us continue further and see. As I said yesterday, we are going to start with the next point. This is called as the code reusability. And if I want to see the code reusability, where are you? Where are you? Here it is. So if you want to go for code reusability, there are two things, or there are two ways you can reuse your code. One is called as association and the other one is called as inheritance. Those are two concepts. One of the concepts will give you a kind of hazard relationship and other one will give you a kind of easy relationship. I'm going to give you examples of both of them. First, let us start the simpler solution or the simpler case. The simpler case is an association. Now imagine that you are having a kind of a class. Again, I'm going to say person here because a person is something which is simple to understand. So imagine that we have a person and the person is going to have a kind of members like person's name. I'm going to split that address into three parts. Let's say city, state, and country. And for example, each. So let's say this is underscore name is equals to name underscore. Let's start with the city. City is equals to city. Then self dot underscore state. State is equals to state. Self underscore country is equals to country. And probably the last one is self underscore age is equals to age. Nothing other than a print info is required for this demonstration. So I'm going to go back here. We'll implement that print info and we'll try to print all the other members of the class. So probably I'll say this is the name, self underscore name. like this. Sorry, name. Probably, I'm sorry, it's not going for the second line. That's fine. So this is where I'm going to say, maybe I'll say this one here and this one here. I'm sorry, what the hell? This one here, this one here. This is an address. Okay. So this one here, leave it. It's better we can write it by hand. This is going to be city. This is going to be state. And this is going to be a country. So this is how we are going to manage the stuff. So this is going to be a country. Forgot to mention that here. This is going to be a state, and this is going to be a city, and finally this is an age. Very simple class. So I'm going to create a person object by saying p1 is equals to person, and I need to pass a few parameters, like this is my person 1, city, let's say Pune, state, let's say MH, that's Maharashtra, and a country none other than India, and probably I'll say the age is equals to, let's say 10, who cares. So imagine that we have a person object p1, and I'm going to call that print info. It will print all the details. Something is not right exactly, address is not required because we are having city, state, and country. I forgot that. So now we are having a kind of person details, you know. So now I'm going to come back here, just say that this is end of the person story. So let's add that 40 or 60 whatever characters. So now I can see this is how the person is getting constructed: person's name, person's age, person's city, person's country, and stuff like that. Okay. Now, when you think about this scenario, let me first go back here and start talking about what is happening behind the scene, because this is important to understand the difference between association and inheritance. No? So when you write this class, probably should I? Should I or should I not? Okay, let's do it later, because now the class definition is a little bit bigger. So let's do it in a moment. So let's imagine one more class. Say there is another class called as a home. So home class is nothing but a class where we are going to talk about the home or house, for example. Instead of saying home, I'll say house. House can be anyone's home. So probably I'm going to say underscore underscore init, and let's say owner name, for example, owner. Maybe again where that house is located. So there is a city, there is a state, and there is a country. Okay, and maybe the zip code and other things required, whatever you want to add it there. So again, I'm going to say underscore underscore owner is equals to owner. Do I need to? Okay, fine. So underscore underscore city is equals to city, and then self underscore underscore state, which is equals to state, and self dot underscore underscore country is equals to country. So this is how we are kind of setting up another class called as house. Again, I'm going to print that right here and say this is a print info. And in this print info, I want to print almost all the details of this house. So probably I'll just say that this is going to be the house details. And probably this is how we are going to print the house details, saying this is going to be the owner name. Okay, so this is going to be the owner, self dot underscore underscore owner. And again, print city, which is equals to self underscore underscore city. Again, print say state, which is equals to self underscore underscore state. Finally, that's print say self maybe country, for example, which is equals to self underscore underscore country. That's it. Let's create a house example or house object, and you can see that h1 is equals to house, for example. Maybe the house is having an owner, let's say owner 1, who cares again. City, let's say this is in Mumbai. Maybe the state again in Maharashtra, and country is India. That's it. Again, I'm going to say h1.printinfo, print info, and probably if I say run, I'll get the details of that house. So probably everything is looking good. I mean, if you look at this code, there is nothing wrong. Everything is perfectly fine. Everything is giving me the right output. Things are really looking okay. The only problem here is, again, it's not a problem, but it's kind of a suggestion. So the only suggestion here is, seems like both of them are having few things in common. So probably a person is also having an address, which is splitted in city, state, and country. And a house is also having an address, which is splitted in city, state, and country. So it's it turns out to be house and person, both of them are having one thing in common, and that is address. So generally we say that A person has an address and house has an address. So if you look at the requirement here, it seems like we unnecessarily are repeating couple of lines. First, we are kind of writing this code here to accept the city, state and country. Then we are printing city, state and country for person. We are doing the same class. We are doing the same thing here. We are accepting city, state and country for house, and we are printing city, state and country again in house. So probably when you see this kind of scenario, it turns out to be few lines of code unnecessarily gets repeated. One of the benefits of having code object-oriented coding, object-oriented programming language is you can reuse the code as much as you can. So if I really want to reuse the code, one thing that stuck to my mind is like, can I not get all those lines out of this both the classes and try to reuse them? The answer is yes, we can. So again, looking at the requirement, it seems like 1, 2, 3, where we are setting the city, state and address, and 1, 2, 3, where we are printing city, state and address. Those lines I can take out from both the classes and create a separate class out of them. And that class, I can use it in my person and in my house. So how do we do it then? To do it, probably I'll keep that for your reference, page 2.py, and then we'll continue further into page 3.py. So this is a simple example where I decided to go for person and house, but I'm going to literally copy and paste and then refactor it. So you will understand what is currently going on, and you will have two copies of it. One before changes and second after changes, So I'm in page 3.py right now, and right inside this one, I think I want to refactor this. I want to change the logic here. So how do we do this? To do this, it seems like I can create a separate class. Now, probably I'm dealing with city, state, and country, which are the part of an address. So probably I can create a class named address, and this address class, as usual, will going to have that underscore in it, and there we will pass the state, maybe country. I'm sorry, city, state, and country like this. Okay. Then I'm going to add the objects like this, or I'm going to add that city, state, and country like this, whatever it is. And then I'll add a function, I'll add a method like print address. Print address. You may say print info as well, but it's okay. And probably I'm going to take these 3 lines and put them right here, So this is what I wanted to do. So I wanted to share that code or the bunch of lines with both the classes. So I took out those 3 lines in 3 lines from that init and 3 lines from that print info function, print info method. The same thing I'm going to do here. So probably I'm going to remove these 3 lines from here and remove these 3 lines from here. Very nice. So you see my code length is a little bit decreased. Now later on, if I have any more class which is going to need an address, I can easily reuse that code here. See, I have not yet added that address support into my class yet. I mean, person is just getting that city, state, and country, but it's doing nothing with them. We have to do something with it. But let us see what we can do here. So when you are in person, it seems to be city, state, and country. These 3 things need to be added into the person. But instead of adding them to the person, what I'm going to do here is like, I'm going to create an object of address and we'll put it right inside of this. One more time. When we are creating an address of, when we are creating an object of person class, I want to put that city, state, and country not directly inside it. I want to do it inside an address class object, and I want to put that object inside the person class. What I mean by this is here, I'm going to create a new member or a new attribute called as an address, and I'll create an object of it, and then I'll put it here. So what I need to pass here, city, state, and country. See if you can understand. So now I have created a separate class, something like an address. That address object I'm keeping inside the person classes object, and then I'm referring it by using a reference underscore address. Now how do I print the address then? To print the address, I'm going to come back here and say, now address is not a simple value member, or it's not the one which is going to store the value. Rather, it is the one which is going to put a reference of that address object. Which simply means if I want to print the address, we'll have to say self underscore address dot print address. Print address because the address is pointing to an address object, and that address object is having a method called as a print address, which is going to print the city, state, and country. Let us see if that really works. So probably I'll put this house in comment for a minute, and then we'll think about that person first and see if we are getting the similar output. Of course, it is exactly similar. So partially name and age, they are coming from person object, and the city, state, and country, they are coming from address object. If you want to get more or better picture, let me say print p1 underscore underscore dict underscore underscore, not doc, it's dict underscore underscore. Let me just go back and say run, and you will see that name is directly added into the person object, age is directly added into the person object, but city, state, and country, they are not there in the person class object. Rather, we have added them into address class object, and then we have added them inside the person class object, something like this. If you really want to see that person class object, this is how it looks like, which means I'll show you that diagrammatically what happens now. So probably I have this class, rather I have two classes here, rather three classes here, but let's start with the first class now. This is going to be an address class. Watch what happens. I'm going to talk about only those two classes, address and person, for example, because ultimately the things will remain same. Doesn't matter whether it is an address and person or address and house. So both of them will remain exactly similar. So this is my first class, address, and probably I have the second class as well. So let me just copy this and paste it here and see what exactly it is, how exactly the things will get implemented here. So this is how we are kind of creating a person class object. Okay, this is the person class, by the way. So if it is a person class, it seems like it's very small. Let me just change this to 24. My God, what the hell? What was that? Was it 24 or was it 18? It was 18, right? So why is it too small? Okay, it turns out it's 18. Fine. So this is a class person. Sorry, my bad. Should I not? Yes. So this is 18, and probably, yeah, now this looks okay. So now we are having two classes. See, one is the address class and the second one is the person class. Important thing here is this line. When you create this, when you execute this line, probably you can see that it is kind of creating a reference first, and of course it is going to have the object pointing to that reference. So let us see what does it do behind the scene. Okay, should I or should I not? Okay, let's do it. So this is the person class object we are creating. Now please pay attention to the way we are going to pass the data here. So we are passing person1, Pune, MH and India, and then 10. So Pune, MH and India, they are getting added or they are getting referred by using city, state and country, and then we are passing those city, state and country to a different class or different class object, which is an address class object here. So this is the important stuff. Let us see what does it do behind the scene. So behind the scene, it creates a reference as usual. This reference is going to be your P1. So the P1 is going to store the address of another object as usual again, which is going to have the reference, which is going to have all the data and the reference for another object. Let's do it one by one. So this is 0x10,000 as usual. Somewhere here, somewhere here. This is going to be 0x20,000 as usual. Again, this is an address of this reference. This is P1, which is a kind of a reference. You know that now. Okay, so this is P1, and this reference is pointing to that memory location. So this is something that we have discussed many a times now. It's nothing new to us. So this is how the P1 is pointing to this memory location. Inside this memory location, we have added two members. One is this, and a two, this, and a three. It's not a simple value like age and name. It's going to point to another memory. Okay, so let us first add that name. See how does it look like. So when you want to add that name, this is how the name will look like. So you can say name, which is equals to person one. That's it. The value will get directly stored right inside this. Next one is age. I think it's better we can say underscore 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 age. It seems like we have passed a value 10, and that's the reason why you can get it like this. Okay. The last one is underscore underscore address. It's a little bit different than these two. So probably let us see what does it do. What does it point to? and then probably you will get what's exactly happening here behind the scene. So this is how the object gets constructed, and probably you see that name and age, both of them are storing actual values. Actual values in a sense, both of them are having the data inside it, but the address is a little bit different. So in case of address, it's not going to store the data. Rather, just give me a minute. Once we are done with this, I'm going to create one more object, and that object will be referred by using this address. When I say one more object, watch this. Probably I'm just going to move it a little bit further here. So probably I'll get some more data, more space for the address object. See, the address object is going to get pointed by using the another object. So seems like address is going to point to another object here. So this is the other object I'm talking about. And right inside this object, we are having three things. You know, this is an address class. So when address class gets constructed, it is going to have city, state, and country. So probably right inside this, we are going to have city, something like this. Again, we are going to have city. Okay. Then state. This is address class object, and the country. Okay. So probably this is how the data will get added inside another object. City in my case is Pune, I hope. The state in my case is MH, and lastly, country in my case is India. You know, as simple as that. So probably when you talk about something like this object gets constructed with this, this data, city, state, and country, and the data is captured by using this particular input parameter, city, state, and country. So we are passing them to address class object. Imagine the address class object gets created into this memory location 30,000, and probably this 30,000 will be used here to refer that address object. So this is what happens internally. So this is the way the address class object, the person class object gets constructed, within which the address class, the address reference is going to point to this particular memory object. So this is the way the address is going to point to another object, totally separate object than the person object. So this is exactly what it is doing right now. So again, I think you can see that this is going to be my person class object. I'll simply say the person, or better we can say person. Okay, leave it. I'll say person object. Let's make it a little bit descriptive. This is a person class object, and this is going to be an address object. So this is exactly what happens behind the scene. What you see here is generally known as person has a address. I mean, we generally say person has an address, but in terms of maybe you can say in terms of relationship, we can call it as person has an object, or person has a address. So this is what the theme of this particular diagram. Okay. So probably it's like car has an engine. Absolutely. Car has an engine, person has an address, whatever you can think of. So the more important stuff that you need to remember is like there is an object, that's a main object, person class object, and this is pointing to another object called as an address class object. This is how you can do it. I hope you are getting the point here. This is called as a has-a relationship. Not only in Python, in every language, it happens exactly similar, same thing. So you go anywhere and you will find the exact same diagram, memory layout there. Okay. Hopefully, yeah, exactly. Separate class. Vipin is, so the class whose members we are going to use must be defined that first. Not necessary. You can define it later as well, but conceptually and again conventionally, we first declare a class and then we use it. Not necessary. It has to be the case. You can declare person first and address later, and still you can refer it. Okay, but generally for our understanding, we do it like address person later, so it will be easy for us to read the code in a better fashion. Okay, Priti, how the print address came? I hope you know that now, because we are using the print address, because the address is a kind of pointing to an object of person class. I mean, I didn't add anything other than a simple I should have actually. So probably you can say this is an object actually. So this object is having a reference to the method. Now I'm not going to add a method there, but probably I can just simply mention that there is another key. The key here is print address, and this is going to have, let's say 0x. Okay, let's not add anything. So I'll simply say address address or method address. I don't know. I mean, I'm not talking about, I'm not going to write it here, but just for your understanding, I'm saying there is another key which is going to point to the address where the method object is loaded. So this is the print address method. So Preeti, that is answer to your question. Okay. And probably I didn't mention that here. I'm just going to add one more key, and we'll do the same thing there. This is print info inside person class object, and this is going to be again a method address. So print info address underscore address underscore address underscore age underscore name. These are the members of person, and print address, country, state, and city. All of them are address class objects. So this is how the things will generally get laid out in the memory. Okay. Okay, so Preeti, I think your question is answered here. Adesh, like car has an engine, object inside an object. Exactly. Car has an engine, person has an address. All of them are exactly similar. Okay, person has a heart, for example. All of them are exactly similar. Adesh, your question, concept is same, language differs only. Not only language, syntax differs only. Concepts really will be same in all the different languages. Okay. Vipin, still confused with the prop and ops, POP and OOP of Python execution flow. It's not clear. I don't know where you are stuck or what is your confusion. If you can ask pinpoint, like I'm not getting this point, I can explain it one more time. If you make a general statement, then I would not understand which point is, which point you are confused with. So if you can ask a direct question, like this is the point which I'm not getting, I can answer that question and I can elaborate it. Anything that you want me to repeat, Vipin? Like an entry point is an execution start. There is no entry point. I don't know whether you have understood this or not, but ultimately this class is a declaration. So this is not going to get executed. This is a declaration. It is not going to get executed. The first statement that will execute is line number 27. Again, either you are in OOP or in POP, it doesn't matter. The flow will always remain same. The flow in the case when you run your code, it's not going to find any entry point function because Python doesn't have one. I think I already talked about this earlier as well. Python doesn't have any entry point function because Python is a scripting language. And when I say scripting language, that simply means it will start its execution from top to bottom, left to right. So from top to bottom, these blocks, these are the declarations of classes. So we don't, there is nothing to be executed here. It just captures the declaration of address, and declaration of person and puts it somewhere in the memory. Next, it starts executing line number 27 directly because this is the statement that needs to be executed, and that's what it is doing here. So if you look at this program, line number 27 is the first statement that will get executed. Okay, and same is true for POP and OP as well. Yes, Adesh, how magic number works here? I don't know why magic number, all of a sudden, why magic number came into picture. I don't know whether others are aware about even the magic number or not. But just to answer your question, Adesh, magic number will not be given to the Python's application because magic number is the one which is added into executables. So executable is the one which is having the assembly code. I mean, every program is having it, but Python's program is a textual code. So there is no magic number in it. I think, Adesh, that answers your question because we are not compiling it. When it gets compiled to something else, it will definitely get a magic number. And magic number is the one with which your operating system is kind of understanding, or operating system is kind of saying that whether it is made for it or not. Okay. Okay. Those who are not having idea about magic number, leave it. It's nothing to do with Python. Maybe you just ignore that. So pretend as if there is nothing called as magic number. And anyways, Python doesn't have one. So no need to talk about it. Okay. Exactly. Sangram, yes, magic number is used in the compiled languages, and magic number is inserted by not the compiler, it is inserted by a linker. Okay. Anyways, leave it. Utpal, leave it. That's nothing to do with the Python. Okay. It just happened to be another question from another world. So you can pretend as if there is nothing called as magic number. And anyways, in Python, there is nothing called as magic number, to be precise. Coming back to the topic again, it seems like we are discussing something called as a hazard relationship. For me, important thing is this statement. When I say person has a statement, you should always imagine a diagram like this. There is a person which is having a reference to an address object, and you are managing two objects at a time. I mean, address object is managed by persons, address underscore address, and address reference. So this is how the hazard relationship is implemented. Can you just tell me, like, what should I do in case of house in to get the same feeling here, to get the same idea here? If I want to do the same thing, if I want to use that address class here, what am I supposed to do, by the way, in case of house? How do I do this? I don't think I need to change this one. All I need to say here is city, state, and country. I want to use it somewhere. Can anyone give me an idea? How can I do it? Because I know that house has an address. So basically there is also a kind of relationship I can find. Anyways, can someone tell me, how do I do this? Same way, exactly. Same way in a sense, you have to come back here and create a reference of an object. So self underscore address, which is a reference to an object of address class. And then you can pass city, state, and country. Absolutely. That's it. And when you are printing the details, don't forget to say self underscore address dot print address. That is how we can do it. When I say run, nothing is going to change. Ultimately, what output I was getting, I'll still get the same output. The only difference is the code is much more readable. The code is much more elegant, and more importantly, because we are reusing it, the code length is also decreased. So imagine there are 10 different classes where the address is required, and now those 10 different classes will still refer or still reuse the class address. That is the beauty of using object-oriented programming. So object-oriented programming is meant for reusing the code. And when I say reusing the code, one of the reusing techniques is something called as an association. So with association, we are going to represent a has a relationship. So this is a kind of has a relationship. For example, student has an address, company has an address, person has a name, company has an employee, department has a professor, and so on and so forth. So imagine that these are different classes. There is a class called as a company, and there is a class called as an employee. So we can say company has an employee. There's a class called as department, there's a class called as a professor, and I can say department has a professor. So that way you are kind of reusing the different classes. And this is a technique known as something called as an association. Now association comes in two flavors. In Python, it is always an aggregation, or maybe you can say it is always an composition, depending on how you are taking a look at it. This is technically it's association, but logically it can be aggregation or it can be composition. Now what is a composition and what is an aggregation? A composition is also has a relationship where there is a loose coupling or weak relationship. Now what do you mean by loose coupling or weak relationship? Simply put, if I look at these two classes, class like address and class like person, it's not like if I leave person or if I take out person from, if I take out address from person, person will not leave. So the thing is, if there is a relationship between person and address, and if it is a weak relationship, weak in a sense, if I take out one class or embedded class, embedded in a sense, the inner class out of the outer class, then if outer class exists, if outer class can survive, this is called as a weak relationship. So precisely speaking, if I take out address from a person, person can still live. Look at the real life example. If I do not have address, I'm a living person. I'm a living I'm living entity. That means address is not mandatory. Address is not compulsory. But think about another example. Another example like a car has an engine, or room has a wall, or human has a heart. Now, when I say car has an engine, and if I take out engine out of the car, you know, in car will not survive. Car will not work without engine. So engine is a part of car, or car is composed of an engine. So again, this is exactly same scenario what I just mentioned earlier, but technically speaking, logically speaking, the relationship is very tight or very strong. In a sense, when you talk about the car and engine, you cannot take engine out of the car and expect car to work, because car depends on engine. It's not like person depends on address. It's not like student depends on address. It's not like company depends on employee, not only employee. There are many different things out there in the company. So if you take company out of if you take employee out of a company, the employee can exist, outside the company, and company can exist without that employee, which means both of these entities will live forever even though they are not associated with each other. In that scenario, the relationship is called as a weak relationship or loose relationship or loose coupling. It is referred as, logically it is referred as aggregation. When you talk about the composition, the relationship is kind of tight or it's a kind of strong. Programmatically, there is no change in Python, precisely in Python. In other languages, the things will be implemented a little bit differently, like in Python, in C++ or in Java. Those things are completely implemented differently, but in Python, it doesn't matter. So I'm talking from the Python's perspective. Association is generally referred as hazard relationship, and the relationship comes into two flavors: weak relationship and strong relationship. When we talk about the weak relationship, we use the hazard word to say that the weak relationship called as an aggregation, and to say that it's a strong or it's a tight coupling, we use composed of or part of, that represents a strong relationship. Both of them are nothing but the association examples. Programmatically, it doesn't matter. So if I want to implement that car and engine very quickly, let me come back here. Let me just go back to page 4.py, and there we can implement this very quickly. So technically or programmatically in Python, there is nothing going to change. So this is an engine. Let's say underscore in it. I'll just put the engine name. Nothing other than that is required. And I'll say print info. This is engine's print info. Print. Let's say engine info. Something like this. So probably I'll just say that this is engine's info, and I'll say what is the name of that engine. So probably engine name, which is equals to self dot underscore name. That's it. Now I'll have a car. I'm sorry. Now I'll have a car, and you know that car is going to have other things. Other things like model and engine. That's it. More than sufficient for me. Engine name. So probably I have an engine name. If you want, you can add some other details as well, like fuel type and other things, so on and so forth. So probably I can just come back here and say model is equals to model. Right now I have only one parameter, but in real life you may have multiple, where you can create an engine class object and you can pass whatever parameter you are supposed to pass. And again, in case of this, I'm going to create a print info function. And in this print info function, print info method, I'm supposed to print the car's name. So this is going to be print, say, car info. So this is the model, not name. This is the model, which is equals to, self underscore model, and print. This is not print, sorry, my bad. It is going to be underscore engine dot print info. I hope you can understand. We are calling a print info method on engine because we know engine is creating an engine class object. So technically speaking, there is no difference. So probably I can say car is equals to a car, which is having a model, let's say i20, and what is an engine? Let's say V6 turbo, whatever the engine name you are having. And then you can say car dot print info. So if I say run, you will see the car's info, and within this car's info, you are having the engine info as well. Technically speaking, we don't have any changes here in Python, because Python by default uses the association. There's no difference between aggregation and composition programmatically in Python. It's just a logical difference, So when you are in other languages, you can keep different pointers, or you can put one object within another object, and that's how it differs. But in Python, because there is no pointer support, it's completely same. I mean, there's no difference at all. So this is exactly the difference between association when you consider it as an aggregation, and association when you consider it as a composition. This is a logical difference, at least when you are in Python. I hope you can understand that, right? So composition is a strong relationship, aggregation is a weak relationship. That's what you need to remember, okay? Okay, Preeti, that answers your question. Very good. Vipin, is there any keyword that might be able to differentiate? No, I said that there is no difference between a kind of aggregation and composition. It's just a logical difference. And again, you have to understand this. Like for me, I know car and engine, the relationship is kind of a tight relationship or the strong relationship, or it's generally called as a tight coupling. Then I can say that it is a composed of. And again, just to say that it is a composed of, you can say a car is composed of an engine, or engine is a part of car, whatever you can say. So this is a kind of representation of how you are going to reuse one class into another class. This technique is called as hazard technique, hazard relationship precisely. Okay. Yes, Chandrakant, means both have the same code. Yes, both are going to have the same code. I think you got both the examples here. Page 3, you see an address and person, which means person has an address. And in the page 4, you can see car is composed of an engine, or engine is a part of car. So this is a tight coupling and this is a loose coupling. So person and address, both of them can live separately or individually, even if you break the relationship between them. Here, if you break the relationship, car is not going to work on its own, and engine on its own will do nothing, because engine without car is useless. Car without engine is also useless. So basically they cannot survive on their own. They have to come together in order to work. In such scenario, we call it as a composition. Composition means composed of. A composed of relationship will be used only when you see the objects cannot live on their own if you break the relationship between them. Okay. Have you understood, guys? Any questions so far? If you have understood this, then we'll go to the other example. But if you have any example, if you have any question, just please ask me right now. Pranit, in real life scenario, this is logical difference might convey properly. Exactly. From logical point of view, it is just a kind of a difference that says whether the relationship is tight or loose. That's the only thing. But I mean, when you are in Python, that's logical. But when you are in other languages, I'm not bothered about the other languages at this moment, because this is the Python course and we just talk about only Python. So in Python, see, to be very honest with you, I don't even need to talk about all of these things. I could have just said there is an aggregation and we would have continued with our own life. But I know that in other languages, you might have seen aggregation is a part of association. So I'm telling you the truth here. So aggregation and composition, these two are generally called as the type of associations. In Python, both of them are seen. In other languages, association is implemented differently and composition is aggregation is implemented separately and composition is implemented separately. Okay. So in case of Python, both of them are exactly similar when you are implementing them. Logically speaking, yes, you can always see the difference. One is where the classes or the objects can live without each other, and in other case, they cannot live without each other. I hope, Pranit, you must have got the answer, or you must understand now like what exactly is the scenario. Okay. Okay, so as you say, like, yes, you got the point. Let us continue with the next point. Okay. Now, this is a point where we are trying to reuse the classes, but not following the same relationship. See, here we were using has a relationship. Okay. Now, let us take a look at something called as inheritance. For me, inheritance is little more important than association, because most of the cases, and in Python at least, you will find inheritance more often than aggregation. I mean, aggregation is also required, or maybe association is also required, but more often you are going to see is inheritance. Let me give you an example. Let me come back here and say this is page 5, and let's see, I have a very, very simple scenario for you. See if you can understand. I bet you can, but let's see here. Again, I am going to use the same class one more time. There is a person, as usual. The person is going to have something like a name, address, and something like an age. You might wonder, why am I using that person class all the time? I'm using one class so that you can understand, like, one class can be used in very different contexts. So if you understand one class and if you understand the use case we are talking about, you can definitely replace it with other classes as well. And 1 minute, once we are done with this, I'll give you a couple of other scenarios as well. So imagine that we are having a person class here, and the person is having the name. So again, underscore underscore name is equals to name. Maybe I'll say self underscore underscore, what is that? Address is equals to address. I'll do one thing. I'll just use a public member for now. Don't want to use it underscore underscore all the time. I'll say this is age is equals to age. And as usual, there is something called as a print info, which is going to be, which is going to be printing all the details of that person. Like this is the person's name, self dot, sorry, my bad, name, print self dot, address is equals to self dot address, and print f age is equals to self dot age. That's it. Okay, so now we are having a person. Let's say P1 is equals to person, and here we want to pass name, address, and age. Name is going to be person 1 as usual. Address is equals to Pune, and age is equals to 20. Who cares? Sorry. And then P1 dot print info as usual. There is nothing great about this program. It's very simple to understand. We are creating a person class object, keeping the three things: name, address, and age. I'll keep this in comment for a minute, and I'll go for another class. Think about this. Maybe I'm thinking about another class, let's say employee, for example, employee of a company. So probably think about employee class now. So probably I'll say this is an employee, where we can say this is a def underscore underscore in it. What are different properties you can think about an employee? So probably employee is going to have a name, employee is going to have an address, employee is going to have an age, employee is going to have a company name, salary, and so on and so forth, so ID and other things there. So I do know that there are few things which are a little bit common. It seems to be common like that person, but still let's first write a or maybe use a long cut, and then we'll see what is the better solution to reuse this code in a different way. So this is an address, this is an age, and probably self dot company name. This is the company name probably, and there is one more thing which is remaining, self dot salary, which is equals to salary. That's it. Maybe I'll say print what is it, employee. So print employee, and I'll do one thing, print person info, and it's better we can say print employee info. What we are doing here, so this is print, and I'll say this is the employee's name. So I'll say this is self dot name. Okay, next one is person's or employee's address. This is employee's age, this is employee's company name, and finally employee's salary. So this is salary, this is going to be the name, this is going to be an age, this is going to be an address. That's it. So probably I'm going to say even, which is equals to employee. Employee is going to have a name like employee 1. The second one is the address, let's say Pune. Age is, let's say, 45. Maybe company name is equals to, company name is equals to company 1. Who cares again? And the salary, let's say this person is getting 10.50 as a salary. Again, even dot print employee info, and when I say run, good, I got the employee details. But now when you talk about something like something like this scenario, it seems like there is a person and there is an employee. In person, we are having name, address, age. In employee, we are having name, address, age. In persons, one of the methods we are printing name, address, age, and employees, one of the methods we are printing name, address, age. It's exactly similar thing what we have seen earlier in case of that person and address. But in this case, I can still do it. I can see that there are few statements which can be repeated, and I can remove those and I can reuse my existing class. But if I say, see, if you look at the earlier example, page 4, I said that something like car has an engine, or in previous example, I said person has an address. In which case, technically speaking, I still can implement it and say employee has a person. But logically, somehow it is not convincing. How can you say that employee has a person? To be honest, in real life, I may say employee is a person. not has a person. Employee doesn't have, when employee doesn't have a person, employee is a person. Naturally, employee is a person. Person is a human being. I mean, that's a different story. That company these days, they don't believe that fact that employees are living things or living entities. They treat them as resources, and they keep on sharing the resources with different projects, and they keep on assigning different work to them, and they keep on living. That's a different thing. But anyways, coming back to the real world, I know that employee is a person. Yeah, employee is a person. I got convinced now. Instead of saying employee has a person, it seems it's better to say employee is a person. Think about other example. Let's say I have a class called as a player, for example. So player, it doesn't make any sense to say player has a person. I may say player is a person, right? So in that case, whenever you see a relationship where instead of using has a, if you use is a, that kind of relationship can be represented by using something called as inheritance. It's also called as is a relationship. The other example we talked about earlier, association, it is representing a has a relationship, while the inheritance is representing is a relationship. So what is an is a relationship? It is a relationship between two classes where we are saying one class is made up of another class. Other ways, one class is sharing the members of other class. Let's do one thing. Let me try to rewrite this example one more time with the proper reusing. Earlier we could not, because that was a simple example I talked about. This time I'm going to reuse the code and see how we can do it. Pay attention. So probably I'm going to do it in this way. Should I or should I not? I should not. Wait a second. I'll first start with the basic stuff. This is a pass, because that's a little bit different than what we have seen earlier, and that's the reason why I'm starting with a empty class again. So I have two empty classes. One is person class and the other one is an employee class. Now, I said that earlier, for me, employee and person, there is a relationship. The relationship is like employee is a person. And when I say employee is a person, I can represent it by saying employee in bracket person. In other ways, I can read this line number 6 as employee, sorry, my bad, employee is a person, or in other ways, I can say employee is inherited from person, or in other ways, I can say employee is is derived from person. So whatever you can say, you can say, I mean, you are getting you are saying the same thing in couple of different terminologies. So you may say employee is a person. It's very well known that whenever you say is a relationship, there is a kind of inheritance going on. So saying is a means employee is inherited from person, and the same thing can be also said that employee is derived from person. Again, there is a, I mean, generally there is a saying like when you are in Rome, do what Romans do. So when you are in C++, you can use its terminology. When you are using Java, then you can use its terminology. When you are in Python, we can use the terminology what Python prefers. Python says employee class is derived from person class. In which case, I can see that employee class is derived from person, means person is now considered as a base class, while employee class is considered as a derived class. Please remember, the one we are talking about here is called as a is a relationship. And when you say there is a is a relationship, the one which is the base, this is going to share all the information with the derived class. So employee and person, if you pay attention to these two, it's not like we are sharing the things of employee with person. Vice versa is true. We are going to share the attributes of person with employee. Whatever is there in person will be there in employee, not the other way. If you have seen the other example, here I was having name address age, here also I was having name address age, here in employee I was having company name and salary, and both of them were missing in person, because in this case the person is going to share the attributes, or person is going to share all the members with employee, not the other way around. Okay, so in this context, If you pay attention to the relationship can be written like this. Earlier we were saying, where is it? Earlier we were saying a car has an engine, or earlier we were saying person has an address, but now we are saying employee is a person. This is the way to write it. Is there any proof I can see? Oh yeah, I'll show you the proof now. So probably I'm going to come back here and I'll say that who's the base class of employee? So base class of employee. We are in Python. So in Python, this can be done by saying employee underscore underscore base underscore underscore. So there is something called as dunder base attribute. If I say run, it tells me that yeah, person base class of employee is nothing but person. Okay, that's it. So that proves the fact that person is a base class of employee. So whenever you are thinking about a class employee, you can say that it is derived from person, means whatever is there in the person will come in the employee by default. I hope you are getting it. If you are getting it, now let me show you few things. Please pay attention. I want you to understand this scenario, because if you understand this, then only you will understand 5 different types of inheritance. You know, different type of inheritance is pretty simple to understand, but you need to first digest this concept. See this. I'm going to come back here and create two objects. One is the P1, which is a person class object, and the other one is the E1, which is an employee class object. I'm going to print this both dictionary representation of them. So this is dict for person, and this is going to be E1 dot underscore underscore dict for employee. Okay, let me print this first. And if I run this code, probably both of them are empty. There is nothing in both of them, because naturally, because we have kept them literally empty classes, so both of them will create empty objects. The object will not have anything inside them. Now let us do one thing. I'll keep the employee object empty for now, and here I'm going to create a default initializer. Default initializer is the one which is not accepting any of the parameters. So imagine that a person is going to have a name, address, and age with the default values. See this. I'm going to say self underscore, I'm sorry, self name is equals to name. I'll put it as a as an empty object, sorry, empty name for now. Address, again, I'll put it as empty, and self dot let's say age, I'll put it as a 0. Okay. Please pay attention to the structure or to the code we have written so far. We have added a name, address, and age in person object, not in employee object. Now let me show you something. When you are in person, and if you add name, address, and age into the person class object, and if I say run my code, surprisingly, do you see that the first is a person class object and the second one here is a employee class object? Oh, maybe I can just say that here, so you can easily understand this. Where is it? Here it is. So you can easily understand this, where we are and what we are looking at. So probably you can now say that for sure that what you see here is a person class object and the other one is an employee class object. See this. Person class is having name, address, and age, and automatically all of a sudden employee class was empty last time, but now it is having name, address, and age again. How come it is? I mean, how is it possible that even though I did not put anything in employee, still it is showing me the name, address, and age? How come it is getting those members? Yes, those members are derived from person class, or those members are inherited from the base class. So if you see this employee in bracket person, it seems like employee is derived from person, meaning whatever is there in the person class will be shared with the employee class. It's like parents are giving every single thing to their kids, or kid is getting something inherited from their parent. So this is a kind of exact same relationship you may find inside the object oriented thing. Again, this is the fact. It's not the computer who has who has invented human invented the computer. So basically when these language developers or these language inventors, when they are inventing the languages, when they are thinking about inventing something, they generally study the human being, and whatever they think they find in the real world, they try to imitate them inside the programming languages. So it will be easy for us to understand. In real life, it happens like whatever father accumulates throughout his life, and when he dies, the child of that person generally gets all of his as an inherited property. So that is exactly what happens here in the in object oriented programming. And the same thing, the terminology is also same. In the real world also we call it as an inheritance, and here also we call it as an inheritance. The only difference here is in real world inheritance is implemented sometimes in different ways by yes, by using, exactly as about to say that, by using nepotism or by using something. Here in Python it's technical and it is to the point, you know. So there you can go to court and you can settle something, you can look at the will and then you can settle something. Here there is no will. If someone is going to die, by default everything is going to get inherited into other class. Here there is no one to die. Here whatever is there in the person will be by default inherited in employee. Of course you can control that, but still this is the way you can do it. I hope you can understand this. So whenever you are talking about a person and employee, whatever is there in the person class is going to come in employee class. It's just because employee is derived from person. But what if I'm going to just remove this here and try one more time? You know what happens here? When I say there is nothing in this particular bracket, by the way, if there is no base class, you can remove this as well. It's completely optional. Let's remove it because this is how we have written the code many a time. So if you look at this one, you see that the employee class is now empty, but person class is still having name, address, and age. So the name, address, and age in employee we were getting last time, it's just because of this particular statement. It's just because of line number 13 where we said that employee is derived from person. I hope you can understand what am I showing you and what am I talking about. So basically whatever is there in the person class, that is getting inherited into employee class just because of this relationship. This relationship here is called as is a relationship. Is a relationship is nothing but one class is deriving every single thing from the base class. The one which is getting derived is called as a derived class, and from which class it is getting derived, that class is called as a base class. So person is a base class, employee is a derived class. That is the basic stuff that you have to understand. Abhilash, is derived class can inherit multiple classes? Wait a minute, we'll talk about it. This is one of the types of inheritance called as multiple inheritance, and fortunately Python supports it, or should I say unfortunately Python supports it. We'll talk about that in a minute, but that is one of the types. So hold your question, you will get the answer. Okay, Abhilash? Okay, any other questions so far? Have you understood the basic terminology, the basic use case of is a relationship? Have you understood that? Preeti, your question, what if the things from person does not want to come in derived class? Yes. What if you don't want to do that? Just go ahead and use them as underscore underscore. So basically when I say underscore underscore, that means they are considered as a private, and you will see that they will come into the employee, but these are not employees objects. These are kind of person's object. Again, that is the convention and not the compulsion. So probably when you say employee underscore underscore name, that will not work. I mean, when you say employee inside it underscore underscore name, that has to be underscore employee underscore underscore name. But you see that it is underscore person underscore underscore name. So it will not work on employee. I'll show you a couple of examples later. But for now, I'm going to put it as a kind of a public, so that it will be easy for us to understand first, and then we'll try to restrict those members later. Okay, so let us come back here, and maybe I can keep this example for your reference, and let us understand this from a better example. Better in a sense, kind of an example where we can have something meaningful to share with the employee class. See this. I'm going to come here and say this is going to be my person class. And inside my person class, I'm going to say this is underscore underscore init underscore underscore my batch class, and then this is init. And probably this time, please pay attention because this is a little bit different than what I showed you earlier. So I'll start with the default value. There is a reason behind this. I'll talk about a reason after I'm done with this program here. So probably I'll say this is going to be name, which is an empty right now. let's say address, which is empty right now, again like last time. And probably I'll go back here and I'll say self dot age, which is 0 for now. Okay. So again, last time, as I said, the print info, print person info precisely, which is going to have the print statements for all of them. Self dot name. Okay, so this is an address where we want to print here, and this is an age which I want to print here. That's it. Okay, now I'm thinking about to create employee class, and this employee class is where we want to say the employee is derived from person. Very nice. Now what? I think I want to use all the members from person class. They will be there. I don't have to do anything for that. Maybe I can simply say pass for now, and I'll create an object of person, and then I'll create an object of employee, and watch closely what is the current scenario. So maybe I'll say this is the person. The person is going to have these three members. Even, of course, it is going to have these three members. And probably I'll say P1 underscore underscore dict underscore underscore. And lastly, even underscore underscore dict underscore underscore. Okay. So let us see what happens. When I say run, probably I see the data is getting shared amongst those two objects, or amongst those two classes. Let us see now what happens behind the scene. Understanding this diagram will be again crucial, because we already have done this earlier for aggregation, or you can say association. Now we're going to do it for a kind of inheritance. So pay attention. Should I or should I not? Okay, let's do it first, and then I'll kind of modify this diagram a little bit once we are done with this. Okay, so this is a class we are using right now. That's a person class, and that's an employee class right here. Employee class is something which I'm going to refactor in a moment once we are done with this diagram. So you will understand what is currently going on. I have two objects to deal with. One is the person class object, and the other one is the employee class object. Please pay attention. Both of them are going to be implemented literally differently. I mean, when I say differently, you can see what is the memory layout of these two objects, you know. So if you can understand this, I can bet you can understand anything in inheritance. Okay, so what do you mean by that person? A person is an object which is having three members: name, address, and age, which are going to store the data, and one member, print person info, which is going to store the method address, you know. So probably I'm going to say that there are three members. So I literally put them in this way. So this is a kind of a name. Sorry, my bad. This is a kind of a name which is empty right now. Next thing is an address which is empty right now. I'm not going to say that this is a kind of colon structure. I'm just saying that in real, this is how we are going to see it. Age is going to have value 0, and there will be a method print person info. This is a method, no? So when you look at this object will have all these members. The members include the data members, or you can say the attributes which are storing the values, and the other one is going to be a method. So there is a method called as a print person info. This is how it is. So this is a person class, you know. The person class is having all of these things. For understanding purpose, I'm going to mark it with yellow background. So at least you will see that this is a kind of an object which is going to have all these details inside it, you know. So it's very simple, by the way. There is nothing difficult and there is nothing complicated here to understand. It's just that we are doing it for the first time. So the things are a little bit different than last time. Okay, now let us look at the employee. Now, I hope last time you already have seen it. In my employee class, you know, I was getting all the members of person class. So how is it possible? You know, how does it do the job? So probably it does the job just because of this. Please pay attention to this part, because this is a little bit different than what we have seen earlier in case of association. So this is inheritance, and in inheritance, the things are handled a little bit differently. So inside this employee object, you always will find a kind of a person object. So this is the difference between having a inheritance in place and having an association in place. So when you talk about the inheritance, this is the real picture behind the scene. So when you say the person class is a base class and employee class is a derived class, the derived class employee, just look at this one. This bigger object is an employee. Maybe I'll use a different color for that. Let's use blue color, for example. So what you see in the blue color is nothing but an employee class. And what you see here in yellow is nothing but the person class. So probably you can say this for sure, the person class is having the object of, the employee class is having the person object of person class. That means employee is a person. It's like we are having a god within, and that's why I don't know whether you have seen this, but in villages side, when you go, at least in Maharashtra villages side, when you go there and when you greet them in the morning, they don't say good morning or good night or good evening, they say ram ram. In a sense, you have a ram in you and you have a ram in me, so both of us are greeting to each other, both of the god within us, they're greeting to each other. So they believe in the fact, and this is again not from the villages side, this is again written in kind of our spiritual in spiritual things there. So it's like everyone, we are having a god within. Similarly, in this case, an employee is a class which is derived from person, and it is having a person within it, exactly what you see here. So whenever you create an employee class object, you always will find a person class object. And because person class object is there, whatever is there in the person will become the part of employee class. And that's how we are getting name, address, age, and print info inside the employee. Did you notice something? When I say even, or let's see the P1 first. When I say P1, I see there is a method to call. Maybe I can call this method. And at the same time, if I say even, I can see print info method, print person info method. How can I call that method? I can call that method because I know the employee class is having person within it. I know this is the object which is kind of, the person object is kind of surrounded by employee object, means whatever is there in the person, it will be there in the employee. So when I say employee even, I can call the employee's print info, which will be getting called from that object within. When I say employee's name, you can see that name here, you can see that address here, you can see that age here. It is possible because an employee class is having a person class within it. Whereas if you look at the has a relationship, we say that yes, here a person has an address, right? So where we say person has an address, that means we are not having an object within it, we are having a reference of that object. So reference can be weak or reference can be strong, but here there is no reference. It has to be a strong reference. It has to be a kind of, there is a very strong relationship, or you can say you cannot just take a person from employee up. So you cannot take it out of it, because this is a kind of an object which is made up of person. This is called as inheritance. In inheritance, every derived class, let me make a statement now. Every derived class object will contain, it's a base class object first. This is a derived class object employee, within which you are having a base class object, something like a person. I hope you can understand it now. What is that, Vipin? Can we say in association it was referring to the base class? Here it contains a copy of base class. To be very precise, Vipin, what you are saying is technically right, but logically or terminologically, it's a little bit wrong. Because when you talk about something called as has a relationship, we don't call that address as a base class. I mean, it's a separate class. It's not, it's neither a base class or it's not a kind of a derived class, because base and derived, we use these terminologies only in case of inheritance. Okay, technically speaking, what you are saying is absolutely right. It's like one is having a reference of it and the object gets created out of the main object. In other case, the other object, the person class object, will get created inside the employee class object. So technically speaking, this is the difference between these two, but terminologically speaking, this is a base class, this is the derived class. In has a relationship, there is no base and there is no kind of derived class. Okay, so what you said is right, but terminologically, we don't call it as a base or something called as derived in case of has a relationship. Aisha, your question, want to hide something from base class to derived class. Let's take it an address. How can we? I'll talk about that in a minute. First understand this scenario. So to understand this scenario, you have to first say that every employee class is going to have a person class object, and this is the structure of it. This is the way it is kind of getting constructed behind the scene. So every time you create a derived class object, every single time an employee class will have a person class within it, which means if I create E2, which is equals to employee, again that E2 will have a separate copy. I'm sorry, E2 is going to have a separate copy of its person class object. Don't get confused. Nothing is going to share between E1 and E2. E1 will have its own copy of person and E2 will have its own copy of person. So both of them will be completely different different employee class objects, and within them there will be a kind of employee class objects, and that's how they will share the data from person class objects. Okay, so diagrammatically speaking, you see the difference between has relationship and is a relationship. In has relationship, the object gets created out of the main object and the reference will be kept. In case of inheritance, the other object gets created inside the main object. So this is the relationship called as a is a, and this is a relationship which is called as a has a relationship, or maybe composed of or part of, whichever you think is making sense to your example you are implementing. Okay. Nidhi, if E1 modifies P1, will E2 see that? Of course not. That's the reason why I said just now that these two will be completely different objects. Just imagine the fact that you are having two objects, let's say E1 and E2. This will be the implementation there. So maybe I can say there is an E1 here. Just give me a sec. Let me arrange it in a better way so it will be easy for you to understand. This is P1 equals to person, whatever, and this is E1 equals to employee. You know what, I can just copy this here and say this is going to be E2 now. So understand this now from this diagram. There's no space, sorry, my bad. Just give me a sec. What the hell? Just give me a sec. It seems like we can have this example here so everyone can understand, not only you, Aisha. So probably you can get it this way. So there is a P1, there is an E1, and let's imagine that we are having one more example, one more object of E1, one more object of employee. We are calling it as, let's say E2, for example. So let's say this is an E2 equals to employee. Let me just copy this from here and say this here. So now hopefully the things must be clear to you that when you are talking about modifying E2, let's say you are modifying E1, say E1's name is changed to E1, for example. So where will you see that E1? The E1's name will be modified right here, while E2's name will get modified here. So probably now you can say that these two are completely different, you know. So even if E1 is getting modified, E2 will not see it. E2 will get modified, E1 will not see it, because these are two completely different objects. I think Nidhi, you got your answer, right? Shrikant, if we modify P1, then E1 will modify. I hope you see this here. If I change the P1's name, or let's say P1's age from 0 to 30, for example. So this person is of 30 years old. You see that there is no change in E1 and E2 because this is a completely different object. So whenever you talk about creating an object, whenever you see this person parenthesis or employee parenthesis, always imagine it is going to create a separate memory location. And because there are different memory locations, modifying one memory location will not change anything in the other memory locations. Okay, so that's how the things are implemented, Shrikant. Priti, your question, only HR knows about all E1. True, that is okay. Sangram, your question. So we can create a person which is not any employee from person class, and we can also create an employee which always be a person. Not really getting what you're trying to say. Let me try to digest this, what you said. So we can create a person which is not any employee. We are saying when you are saying P1 is equals to person, this is not employee, this is a pure person object. And other statement you made is we can also create an employee which always be a person. That's exactly what we are doing here in E1 and E2. So when you say employee, you are creating an object of that employee, you always will have a person within it. Okay, yeah, that's correct. Guys, have you understood the difference between has and is? This is has, this is is. Any questions so far based on the discussion we had? Class person age is not getting to employee even. Class person age not getting to employee. No, you saw that, right? You saw that here, isn't it? See, age is already there. So of course it will be there. Vishal, I think it's better you check the code, because age, if it is there in person, it has to be there in employee. Okay. Not only here, maybe if I just go back and try to print the E2's dictionary, you will find it there as well. So E2 underscore underscore dict underscore underscore run, and you see it's there as well. This is P1, this is E1, this is E2. You will have it everywhere. Okay, so things are kind of moving steadily, and I hope you are getting this. Ketan, little bit confused, but with an example, it will be cleared. With an example, it will be cleared. I think we are talking about the same example here. So looking at the person and employee example, you see the person is the one which is having the name, address, and age. Employee is the one which is having nothing, but it is getting all the things from person class, okay? Now, time has come to add something more than person class into an employee class. So person class is giving you three things: name, address, and age. Now, I know the employee class is going to have its ID. So probably I'm going to come back here, and instead of making it a kind of a pass or an empty object, I want this object, I want this class to have, let's say, employee ID and company, whatever. So maybe I'm going to come back here and say this is an init, and this is an ID. Oh, why am I doing it? Maybe I can do it in this way. Self.id, so self.id is equals to 1, for example, or maybe let's start with the zero values, and company name, which is equals to empty. Now watch what happens when I say run. It seems like it's giving me an error. It says line number 8 is where we are getting an error. Oh, sorry. P1 print employee person name. Exactly. So this is going to be causing a problem. Just give me a second. Before we talk about this, I want to show the dictionary. I know why it is crashing, but I want you to first see the dictionary, because whatever we have just discussed, it is not at all following the concept here, like the other languages. So it's kind of a bummer for us. Like, I was thinking about to add ID and company on top of name, address, and age, which means I was thinking in a way like we already have got the name, address, and age from employee of the person class object. It's better for me to just add ID and company on top of it, so that I can say employee is having ID, company, name, address, and age. But things are turned out to be different. I mean, things are like, oh, I lost name, address, and age from E1 and E2, and I just got only ID and company, which was not something I was expecting. I was expecting like person will have name, address, and age, and E1 and E2 will have name, address, age, and ID company, something like that. But it turned out to be completely different. What could be the reason behind this? The reason behind this is pretty simple to understand. So please pay attention to that diagram one more time. Not this, the other diagram one more time. And try to digest this scenario. What has just happened and what is the solution to this? If you don't understand this, I can bet you will not understand any of the next examples. So pay attention to what am I trying to show you. Last time, without I doing everything, I mean, without writing a single line of code, when I kept it as a kind of pass, everything was working flawlessly. I was getting the name, address, and age in both E1 and E2. All of a sudden, when I added my own initializer, I lost name, address, and age, which means I just got only ID and company. So what has happened behind the scene, because of which I lost the data, and is there any way I can add them back in my code? So that is a question that I have to answer here. See what has just happened. Before you were having anything, you were just having a pass, means, let me now reveal the secret, what was the case it was doing behind the scene, why it was working earlier. So behind the scene, when I was having a pass, on its own, employee was adding a kind of initializer, which was calling the person initializer within it. So person dot underscore underscore init, and passing the self here. Let me say, put this in comment and make it as a pass. So when you are writing pass, or when you are not writing your own initializer, employee class, this is the derived class, by the way, this employee class was providing its own initializer method, generally called as a default initializer, and it was calling its base classes initializer method. I hope we already know what the job of init method is playing in Python. It's the when it is going to add all the members inside your object. So this was the case when I was doing nothing. Employee was adding its own init, and employee was calling the person dot underscore underscore init. Now you must be wondering why person. The reason is very simple, because you know employee is derived from person. So whatever is here, that initializer method gets called inside the employee. And because of these two statements, what I just showed you here was getting implemented behind the scene. So when I say employee is having an object of person, the reason behind this is this. Before I do anything, or before I add my own initializer method, employee class was adding its own initializer method, default initializer method, and it was calling person's initializer method. So that was something getting done behind the scene automatically. I was not doing anything for that. It was getting done automatically. So because of this, while initializing person class object, you are adding while initializing the employee class object, you were adding the person class object inside a self. Self means inside the employee class object. And that's the reason the person class was getting added in the employee. But all of a sudden, when I started implementing my initializer method, it seems like I did not add that. I mean, I started saying self dot maybe ID is equals to 0, and self dot let's say company is equals to blank. So how do I make this working again? Because now see, I lost that name, address, and age members of person class. So how do I bring them back? To bring them back, I need to add that the person class object into employee class object. So how do we do this? All we have to do here is just write that code one more time. What was getting added behind the scene, you just go ahead and do it. So person init self, that's it. This is the way we are kind of saying derived class object getting initialized, while inside it you can say base class object getting initialized. Very important, within derived class object. So within employee class object, you are initializing the person class object. So now when I say run, look what has just happened. Earlier I was having name, address, and age in person. Now I'm having those three along with ID and company in both E1 and E2. So when you do it, then and only then it is going to bring the person members into your class. It was getting done behind the scene earlier because it was literally calling that person.init person._init__ self behind the scene automatically. When you implement your init, employee stopped adding its own, and because employee is not going to add its own, you have to do it on your own. So I hope you are getting it. So probably yes, Utpal, it's like you have to write your own. That's what we are doing here. And Vipin, is it the approach always better? Whether it is a better or not, this is the way we have to do it in Python. Again, those who are coming from other languages, this is exactly what happens in other languages. The only difference is there in those languages that happens behind the scene. You don't have to call that. But here in this language, we have to do it explicitly by saying person__init__ self, where I know person is the base class and employee is the derived class. So if this is the case, you have to write this code here. Who's that? Amar? Is it compulsory for creation of an object of base class? Yes, and you already have seen it. If you don't write this code, if you don't write this particular statement, you see it's not bringing that person members here. If you really want those person members inside employee class, this is mandatory, and that's the reason why we have to write the code like this. Okay, no problem. Okay, so guys, can you please confirm, have you understood this? because understanding this is a crucial for every single example we are going to see henceforth. This is the statement you will find in every single code, every single time. Okay, good. Good that you are getting it. So fine. I mean, I'm kind of done with getting the basic things implemented. Now let's do something meaningful, because till this time we are just using the default members, like default values like 00 or maybe something like a blank blank. I am not interested in that. I want to add a kind of valid data to my both person and employee object. So see how it can be done. Now this is an example that I wanted to extend a little bit here. So pay attention again. Little bit similar to what we have done earlier, but with small changes, small optimization, should I say. Okay, again, I'm going to say this is the class person, which is going to have a definition in it, which is going to have a name, address, and age. Pay attention to what I'm trying to show you. Today, I'll just deal with only the public members. In the next session, we'll talk about another type called as protected members. But right now, it's okay to have public, age, again def, print person info, print name, which is equals to self dot name, again print address, which is equals to self dot address, and print maybe age, which is equals to self dot age. Okay. The another class which is called as an employee for me right now. So I'm sorry, employee. This is going to be derived from person, and right here, this is again init, which is going to have name. This is the employee's name. This is employee's address. This is employee's age. This is employee's ID, and this is employee's company. Okay. Now this time, the question here is, when I want to bring all the person members into employee, I said that you have to call underscore underscore init of underscore underscore init underscore underscore init dot underscore underscore init underscore underscore of person from the employee's initializer method. So we have to do it here, you know. So we'll have to call that person dot underscore underscore init by passing self. But we can't stop it here, because you know we still see that there are three parameters I need to pass: name, address, and age. Unfortunately, we are getting those values from our initializer there. So address and age. See, out of name, address, age, ID, company, I passed name, address, age to my person. That means my person is going to have the name, address, and age. Remaining ID and company, I'm going to add both of them here. So I'll say self.id is equals to ID, and self.company is equals to company. Again, I'm going to say print. Oh, we'll talk about this in a second. And then we can say now P1, which is equals to, I'm sorry, P1, which is equals to person, which is going to have a kind of name, address, and age. Say name, or maybe I'll say person 1, address, let's say Pune, and age, let's say 20, and say print person info. There is no change. It's exactly what we have seen earlier, just only a difference is earlier we were getting the empty data. This time I'm getting a valid data. E1 is equals to employee. This time I'm going to have the valid data. So I'll say employee 1. This is going to be an address, let's say Pune again. This is an age, let's say 35. ID is equals to 1, and company is equals to company 1. Watch what happens. I'm going to say print person info, and you see that it is printing the information about an employee. Employee 1, Pune, and 35. Do you see that something? See, I'm not getting the employees, employee ID, and employees company. The reason behind this is because we are calling that method print person info, and the method is getting called from person. Person doesn't know anything about the address. I'm sorry, anything about the ID and a company. ID and company, these are the new data members provided by employee. So they were not there inside a person, and that's the reason why person is not aware about them. Now let me modify this diagram a little bit, because now you see the class definition is changed a little bit. Or I'll do one thing, I'll just copy every single thing and go back to the another diagram, and we'll put it there, and then I'll modify it here. Instead of modifying the original source, it's better we can just modify the updated code right here. So this is the updated code. Just pay attention to what we are trying to say here. This is where we are kind of getting the person class. That's it. And this is where we are now going to get an employee class. The employee class here will be a little bit different than what we have seen last time. It was empty last time, but this time now we are having one more initializer method. I'm going to update the diagram as well, and I'll save the copies of all the diagrams there. Okay, so don't worry about that. I'm going to save all the copies so it will be easy for you to understand what is currently going on. As you must have seen, I love diagrams, and I hope you must be also finding it a little bit helpful to understand the concept. So probably I'm going to keep every single thing and we'll share that right after the class is done. Okay, Prashant, I think, yes, I will do it. Okay, so now let us see what has just changed and how will you find that change here in this diagram, you know. So this is a little bit changed. This is a little bit changed. Now it's not 0, 0 or it's empty. It's rather a valid data. And when I say it's a valid data, you see the person is getting created with some data in it. So, sorry, here it is. So we don't need this one. We need the person one here. So let me just bring that person one here. We'll say that this is the person. Sorry, my bad. This is the one. Here it is. And that's too much. Okay, I'll just make it a little bit smaller. I'll put it right here. Yeah, that's the person one. Okay, so you see the person one is the name. Maybe I'll say that person one. Sorry, my bad. This is person one, which is the name. And probably the second one is the Pune, that's an address. And the third one is something like an H. So this is Pune H, something like this, you know. As simple as that. Do I have any space? No, I don't think so. Let's put it there, and if required, we can adjust the thing. So yeah, that's good. So now this is the change. So name is having person one, address is having Pune, and age is having 20. That's how we have created it. Now let's look at a person. I'm sorry, an employee. This is the one which I'm dealing with. I don't need this one, so I'm going to delete that. It's of no use because we already have seen that. And if we are looking at only one object, it's more than sufficient because the rest of the objects will behave exactly in the same way, you know. So no need to have multiple objects here of the same class. So now I'm going to put that right here. I'll say that this is employee E1 equals to blah, 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 like this. And we'll see what has just happened here. So probably if you pay attention to the E1, this time E1's name, address, and age will have some valid data, not like last time it was empty. So I'm sorry, this time it will be a kind of, what the hell? Okay, fine, no problem. If that is the case, I don't know why. Sometimes, you know, it behaves oddly. It's not developed by Apple, by the way. It's a third-party application, so can be having some bugs. I don't know. Okay, anyways, this is the E1, and probably I was saying like now the data is not a kind of an empty data like what we were getting earlier, but this is a kind of valid data. And when I say valid data, that simply means I'm saying like this. This is an employee. So let's bring it here. This is a Pune value for an address. Sorry, my bad. And probably this is 35. That is an age. ID and company, we'll talk about that in a second. So first deal with them and then we'll deal with the next two. Okay, so you see that this is an employee, this is Pune, and this is 35. Please make sure that you are getting it because these will go inside the person object as we already have seen here. You know, we are passing them passing the name, address, and age to person dot underscore underscore int. So these will go inside the person object. While ID and company, we are adding directly on top of self, meaning if I just come back here and I'll say now inside employee class, we are having two members, ID, which in our case is equals to 1, right? I hope, yes. And the other one is company, and company in our case is company 1. I'm sorry, company 1. So this is how it is. And probably if I just go back and if I say this, you see ID and company, those are created outside the person class object. Please remember, this is a person class object right here. And this is an employee class object. So this is how it is, you know, inside the employee class, there is a person class, and that person class is having the data within it, and the remaining ID and, I'm sorry, the ID is small, but just you can understand that. ID and company, both of them are kind of created outside that person object, but inside that employee class object. Guys, have you understood what I just said here? What I just showed you here? Have you understood that scenario? Okay. Yes. Thank you for confirmation. Hardly a couple of you are saying yes, but I'm assuming the rest of you are having the same answer. So it's okay. So probably what you see here now is the way an employee class is represented in the memory. So every employee class is going to have a person object, and the person's object is going to have the person's name, person's address, and person's age. The ID and company will be stored outside that person object inside the employee. So this is something which is getting done in is a relationship. This is an example of has a relationship. This is an example of is a relationship. This is an example of is a relationship where a derived class is having some more data on top of base class, and here we are just having a derived class as an empty class, and that's the reason in this case the employee class is having exact same amount of data my person class was having earlier. So this is a little bit different. It's just a kind of a real life example of employee class when you are comparing it with the previous or maybe the default class. It's okay. Fine. So this is a kind of a starting point of easier relationship. I hope you must have got the basic stuff now. Maybe in the next session, we'll talk about some advanced properties of inheritance, where we are going to talk about the 5 types of inheritance: single, multiple, multi-level, hybrid, and something like something like a combination of this hierarchical. We'll see that later. So we are going to talk about those 5 different type of hierarchies or 5 different type of inheritance schemes. On top of it, we are going to see one of the most important topics in not only in Python but in all different languages is something called as method overriding. So this is something that we have to see in the next session, and on top of it, if time permits, we'll talk about something called as operator overloading. So this is the plan we are having for Monday. So on Monday, we'll talk about these advanced topics. Provided that you are kind of getting some time spent on these topics on next 2 days, Saturday, Sunday. I hope the next topic or the next session will be pretty much easy for you to understand. Okay. Anyways, with that, we'll conclude today's session. But before we conclude today's session, I just want to give you a kind of a heads up. Like tomorrow, we are going to start with AWS batch. Those who are interested with AWS or those who are interested in the cloud computing, they can at least come from tomorrow, come for tomorrow and after tomorrow sessions. Tomorrow session and after tomorrow session will be completely free. There will be no, there is nothing you have to pay. So this is the free class. I would suggest you to attend it. Though even though you don't want to go for AWS, it's perfectly fine. But now you must have seen cloud is everywhere. And tomorrow and after tomorrow, I'm going to talk about the cloud, only the cloud, and then introduction to AWS. Then starting from next Saturday, Sunday, we'll talk about the AWS certification, other stuff. But tomorrow we are going to talk about the cloud. I mean, introduction to class, introduction to the course, and then we'll talk about more or less the cloud. So please do attend it. Okay, it's free of cost. You don't have to pay for it. You will get some extra knowledge. And I want you to understand that, because there is one more topic. Once we are done with all of these things, we want to go and upload our code to AWS. So there at least you need some basic knowledge. So probably it's a good chance that tomorrow you are going to have the session. Okay. Anyways, you will get the invitation, or maybe you are going to get the pamphlet on your group later, or maybe you must have already gotten it. If not, then you just ask us. Someone from us will send you. Okay, but you attend that tomorrow session. It will be tomorrow at 7:30 to 11. That's generally the timing for our weekend courses. So that's a kind of AWS course. Anyways, do attend that. We'll talk about it tomorrow.
Sir, so it is a weekend course, right? Not the weekdays?
No, it's not weekdays. It's a weekend course, and the weekend course will be having only Saturday, Sunday, 7:30 to 11. Sometimes 11:30, depending on the topic. Okay, sure, no problem. Okay, I think it's better. We can call it a day, and probably yes, and you have to register it for it. Absolutely. So you can register that later, and you can attend it tomorrow. Okay. So let's call it a day right now. So we'll see exactly Monday at 8 a.m. Please spend some time practicing these things. So Monday session will be easy to understand. Thank you very much again for attending today's session. Really appreciate your patience. I'll see you on Monday. Till then, bye bye. Have a very great day ahead and have a very great weekend. Okay, enjoy it. Bye bye.